Hello and welcome to the solution guide for the Postman Problem and its 3 practice puzzles by myself, the Pedaling Pianist. Now before we get into it, you've seen the video length, it's probably quite long. To be honest, I don't want to promise that I'm going to spend hours and hours editing and re-recording things to get it as concise as possible, but what I will do is put lots of helpful timestamps in the video description, and also I won't be remotely offended if you go into your YouTube playback settings and put me on 2 times speed. I would go so far as to say I encourage that. Anyway, this is the Postman Problem as it appears on the Logic Masters Germany page. It's been solved 8 times in about a month, and I'm very grateful to those 8 solvers. A lot of those who managed to solve it put some very complimentary comments on this page, which I'm very grateful for as well, of course. There is also one comment by someone who I don't think did solve it in the end, basically saying that they couldn't because the rules were unclear, and pointed out various ways in which the rules were unclear. And I think, to be fair, he does have a point. They were worded quite ambiguously, so I have since updated the rules. It's bizarre, it really is bizarre, but I actually find it harder sometimes to word the rules to these puzzles than to actually make them in the first place. Anyway, you will see the updated wording of the rules on the Logic Masters Germany page and on the main 9x9 puzzle. I haven't updated them for the practice puzzles yet, but yeah, the practice puzzles are exactly the same rule sets. Anyway, so in order to explain that, I'm going to use this example that I prepared earlier. This is not necessarily correct, in fact it's completely wrong for lots of reasons, but I will use this to go through the rules. Right. Normal Sudoku rules apply. The grid is a city. To clarify, normal Sudoku rules 1 to 9 in every row, column and box. Hopefully if you're watching this video you'll be very familiar with those rules. The grid is a city, and each cell represents either a skyscraper or a road segment. I'll go through my colour scheme in a minute. The digit in a skyscraper cell represents its height in number of floors. Clues outside the grid show how many skyscrapers are visible from the direction of the clue in that row or column. A skyscraper is visible if it is taller than all other skyscrapers between it and the clue. These clues refer only to the skyscraper cells, i.e. road cells are invisible to the clues. So you're probably familiar, well you may be familiar with the normal skyscraper rule set. So what that says is that every digit is a skyscraper. That's a skyscraper of height 3, that's of height 2, that's of height 5, and so on. So if that were the case, the 2 would be obscured behind the 3, the 5 would tower over the 3, so from the direction of this 4 clue you would be able to see obviously the 3 straight away, and also the 5 towering over the 3, and also the 9 towering over the 5, but everything else gets obscured by the 9. So if that were a normal skyscraper clue, that should say 3. However, in this world, only some cells in the grid are actually skyscrapers, and I have used green to be my skyscrapers. It's a weird colour scheme, but it works for me, and I think it creates nice contrasts between all of the different colours that I use. So green represents skyscrapers, so only these 5 cells in this row are skyscrapers. Everything else is flat. It's just a road. So 3, 9, 8 and 1, they are just flat. They do not get seen by this skyscraper clue. So the cells that we do see are the skyscraper of height 2 at the front, the 5 towering over it. We don't see the 4 because it's obscured by the 5, but we do see the 6 and 7 towering over the 5. So that is a correct clue in this context because we do see exactly 4 skyscrapers. Even though there are 5 skyscrapers in the row, we only see 4 of them. So that is how the skyscraper rule works. Hopefully that's fairly uncontroversial. I don't think the comment was complaining about any of those aspects of the rules. It's more this next paragraph that I really had to work on rewording. So, you are a postman. Draw your route, which must be an orthogonally connected loop that travels only on the road and does not branch or enter the same cell twice. In order to deliver post to every floor of every skyscraper as efficiently as possible, your route must visit exactly n of each skyscraper's neighbouring cells, where n is the digit in the skyscraper cell, its number of floors. Neighbouring cells are 1 orthogonal or diagonal step away. So what I've done, all of the yellow and grey cells are all road cells in this example. It's just that the yellow cells are road cells that get used by the postman on the postman's route, on your route, because you are a postman in this case. So it needs to be one orthogonally connected loop. Obviously we've got two here, one up here and one down here, so that's immediately wrong. The reason I've drawn this is because there is some ambiguity about whether the loop can cross. So my original wording was the loop must not branch or cross itself. But one point that was made in that comment was, well, what if the route does this kind of thing, but actually the route is kind of going, like this at that point. So the route never actually crosses itself. It is still just one loop. It just kind of bumps into itself in the middle of this cell, and then the two kind of loop segments kind of go away from each other in right angles. Is that allowed? The answer is no, it's not meant to be allowed. So yeah, I don't know the clearest way of saying that. I suppose you could say every cell that the loop visits must have one entrance to the cell and one exit to the cell on the loop. Something like that. I don't know how to do it without being overly wordy. If you are a Sudoku constructor and you have any ideas or advice about how to word this rule set, or any general advice about how to approach the task of wording rule sets, which I find bizarrely difficult, I would appreciate any advice. But yeah, that is not meant to be allowed because we are entering the same cell at two different points on the loop. It's also important to note that the loop never enters skyscraper cells. We can never go into the skyscrapers. Imagine that you are, I don't know, on your bike or in a little post van, and obviously they have to stick to the roads. You can't get out and walk into the skyscrapers. Maybe that's a sensible way to think of it. Good. And then the second half of the paragraph, in order to deliver post to every floor of every skyscraper as efficiently as possible, we need to do something like this, where you can see with this 5 skyscraper, it has 5 neighbours, both orthogonal and diagonal, that are on the route, on the postman's route, and therefore that 5 is satisfied because the postman has 5 opportunities to deliver post to all 5 floors of the skyscraper. I don't know how much you want to get into the metaphor, but yes, that 5 clue is satisfied. That 2 clue is satisfied because it's got 2 neighbours on the route. The 4 clue is satisfied, and so on. So hopefully that bit is fairly clear. Orthogonal, I didn't explain what orthogonal means. You probably know that if you're a Sudoku enthusiast watching this video, but it just means that we can never travel diagonally like that. That's not allowed. In order to get from those two, between those two cells, we would need to take an orthogonal route like that, which is vertical or horizontal or a mix of both. Good. Then this bit, your route need not necessarily visit every road cell, and therefore for ease of solving, a third cell type, e.g. field, may be used to show cells that are neither skyscraper nor part of your route. So that's what I've done here. I've just coloured in grey anything that isn't a skyscraper, but also isn't utilised by the postman on the postman's route, and therefore it's just a blank cell, basically. So yeah, we could colour them all in the same colour as all of the road cells, but then at that point it becomes quite confusing, because you look at that 5 cell and you think, well, it's got 7 neighbours that are yellow now, and you have to be very careful about checking which ones are actually on the path. So yeah, it just makes more sense to have 2 different colours for your road, or a field colour as well. Good, and that's all of the rules of the kind of postman rule set. The practice puzzles don't have these last 2 paragraphs, so actually I'll come back to them when we get back to solving this 9x9, and we'll dive straight into the practice puzzles now. Okay, the Petite Postman Practice by the Pedaling Pianist. So we only have 1 clue and a given digit in this puzzle, and that is saying that there are 2 skyscrapers in this column. Now, can the route ever visit this column? If it does, it has to get back out again because the route is a loop. So we need to have some kind of U-turn like that, and now we've only got one cell that's available for potentially being a skyscraper. So that's never going to get up to 2. So that makes no sense. So we can never visit that column of the grid. So instead, the route will look either like that, or like that, or like that. Now, I'm going to be honest, you basically just have to try all 3 of them out. It's quite bifurcatory, but I feel like on a 3x3 grid, bifurcation can be forgiven. So let's try this one, where all of those are on the route. Well, we can get a skyscraper of height 2 into either of these cells, because, well, if that were to be a skyscraper, it sees 2 cells amongst its neighbours, so it would be a 2. If that was also a skyscraper, it would also be a 2. So we can't have both of them. If we make that one a skyscraper, it would be a 1. So that's fine. We do have 2 skyscraper cells in this column, except from the direction of this clue, only the 2 is visible because the 2 obscures the 1. So that is not going to be the answer. And that's whether we put the 2 in either of these 2 places, it will always obscure the 1. So that's not going to be the answer. Let's try getting rid of that and putting that in instead. Let's just fill in our colours, get rid of that. Now we have a similar position. We can have a 2 in either, not both, but either of these 2 positions, because both of them have exactly 2 neighbours on the postman's route. And then we can have another skyscraper here, which is a 1, because there is 1 neighbouring cell on the postman's route. And that works with regards to this clue, but obviously that's why we've got a given digit in the grid. A given digit in a 3x3 grid, and yet it's still this difficult. Which I'm quite proud of how difficult this puzzle is, given that it's a 3x3 grid. Anyway, the given one tells us that this is not going to work. This is not valid. So, by process of elimination, the route must do that. Now, if we were to put a skyscraper here, it would be a 2, because it's got 2 neighbouring cells on the route. If it were here, it would be a 3, and if it were here, it would be a 2. Well, we need to make sure that 2 of these skyscrapers are visible from that direction, so it must be these 2, and it must be a 2 and a 3. This is neither a skyscraper nor a route, so we can colour it grey, and at this point we can just fill in the puzzle pretty much. 3, 2, 2, there we go, 3. Signed, sealed and delivered. And for some reason I like pausing the clock at 1 second, because I don't like knowing how long it takes me to explain my own puzzles. So there we go. In 1 second we had the puzzle signed, sealed and delivered, with a 3 in the corner, by the way. Oh, did that get just out of interest, did that get... Yes, it did. It did get its confetti. Never mind. Right, okay, let's move on to the 4x4. Now, we can ask a similar question. How many skyscrapers are we expecting to see this time in this row? And again, it's a minimum of 2. We need to make sure there are 2 visible skyscrapers, which means we need at least 2 skyscrapers in this row. And same with here. Now, can the route not enter this row? Are we expecting the route to enter this row? And the answer is yes, because if it stays entirely within this area of the grid, then these skyscrapers will never get visited by the route. So it does need to enter this row of the grid. Does the route enter this row of the grid? Well, let's try it. Let's say it does something like that. Then these would be skyscrapers, as would these. So we can't kind of dilly-dally in row 3 and do that, because then we don't leave enough space for 2 skyscrapers in this row. So we need to basically go straight down and straight back up again if we're going to visit row 4 of this grid. And if we did that, we're going to have something like that, where the circles are the skyscrapers. But you can see that if that were the case, this would be a 2, because it sees 2 neighbouring cells on the route. And as with this, so both of these would be 2s, and then we'd have a clash in terms of normal Sudoku, so that does not work. And what about if we dipped in down here and came straight back out again. In that case, all of these would be skyscrapers, and then this skyscraper in the corner would have to be a 0 because it never gets visited by the root. And hopefully it's fairly clear to see that the symmetrical opposite problem would occur over here, with this one having to be at 0. So the root never visits this area of the grid, but it must visit this row, otherwise we'll never visit the skyscrapers that must exist along the bottom row. And again, it must dip straight in and back out again so that there's enough space for the 2 skyscrapers to exist in this row. And at this point, again, it's just kind of trial and error, to be honest. So can this work? Well, in order to visit this area of the grid, we need to come over here, which means this needs to loop all the way around here. And, well, we have a problem immediately because this is going to be, well, at least 3, because it already sees 3 cells in its neighbourhood on the root, and this is going to be a maximum of 2 because, well, if those 2 are both root cells, then it would be a 2. Well, that would actually make this a 4 instead. But whatever the case, this is always going to be a higher digit than that, and so it won't be possible to make both of them visible from the direction of this clue. So that does not work. The next one, unfortunately, is a little bit more bifurcatory. Can this work with skyscrapers here and here? Well, at first blush, it looks like it could. Again, in order to visit this skyscraper, we need to come over here, which means the root has to do this. In order to get one skyscraper in row 2, to satisfy that clue, we need that to be a skyscraper, so the root actually closes off like that, and that's all fine. And that seems okay, so let's actually just do the highlighting and see what's going on with that. So these are all green for skyscraper. This is a 3, we can just write it in as a 3, and that's a 1 because of just counting the number of neighbouring cells on the root. What about the bottom row then? Well, we have a similar situation to the 3x3 grid. One of these only can be a skyscraper of height 2, and that's already causing a problem because where do you put 2 in this box of the Sudoku? So that doesn't work. We could make this a skyscraper, but it would be of height 1 and it would clash with this. So it's just not going to work in the bottom of the grid if we were to do this particular formation, and that all came about because of dipping into the 3rd row just here. So that's not going to work. Instead, by process of elimination, it must be this, so we can colour that yellow. The skyscrapers in this row must exist here and here. Now, this is going to be, well, we know that the bottom row is never going to get visited by the root. 2 of these obviously do have to be skyscrapers, but I'm going to colour them grey for now just to show that they never get visited by the root. So this is going to be either a 2 if we don't fill in this cell as a root cell, or 3 if we do. So it's going to be a 2 or a 3, and this is exactly the same. It's currently got 2 cells, 2 neighbouring cells on the root, and it has a maximum of 3, so it's a 2 or a 3, but we want to make sure that they're both visible from the direction of this clue, so this has to be the 3, this has to be the 2. So this does get visited, this does not. In fact, actually, it's not going to be grey, is it, because it's part of this clue, so it needs to be a skyscraper in order to satisfy that clue. So the root must enter and leave this cell in only those places, it can't go anywhere else. This is also a corner, so it's forced to go like that, it can't branch back down like that, so it must do that, and this one must continue straight because it can't bump into a skyscraper, and so we have our entire root. That means we can just write the digit 3 into this cell because we have 3 neighbouring cells on the root. We get a 3 here. This sees a 1, 2 and 3, so it's a 4, that becomes a 1, that becomes a 4, that becomes a 1. 3 goes exactly there, that becomes a 2, that's a 1, and these are both 2, 4 pairs, and that's where the bottom clue comes into its own. We need to have 2 visible skyscrapers. The 3 can't be a skyscraper because it only has 2 neighbouring cells on the root. The 4 would never be able to be 1, so it needs to be the 1. So that upgrades to green. and the 2, wherever it goes, must be a skyscraper. It can't go in the corner because that only sees one neighbouring cell on the route. So this becomes the 2, and it becomes a skyscraper. Let's also just colour in that as grey, and the 2, unwinds this otherwise deadly pattern. Jess the cat would be proud. Hopefully you will get that reference. If you don't, I don't know, Google it. There we go. No 3s in corners in this one, but we still had the given 1 in the top right corner, which I found quite a satisfying little theme. Good. Let's move on to the 6x6, and this is where things start to get a little less trial and error and a little bit more fun. Let's just say. So the first clue to look at is, of course, this. No, I'm kidding. It's the 4 at the top. The highest number that you can ever have in a skyscraper along the edge of any Sudoku, whether it's 6x6, 9x9 or 20x20, is going to be a 5, isn't it? Because this cell, for example, only has 5 neighbours. So, can we ever have a 5 along the top row of this grid? And the answer is no, because let's put a 5 here. Let's imagine we have one that's a skyscraper. Sorry, the question was worded wrong. Can we ever have a 5 along the top of the grid that is a skyscraper? If we did that, then all of these cells would have to be along the route. But this is a corner. And whenever we have a corner like this in an orthogonally connected loop type puzzle, we need to go in and out of it like that, in and out of it like that. And so those become road cells as well. And oh dear, we've now only got 1 cell left in the top row, and we need 3 more skyscrapers. So that's never going to work. The 5 just takes up too much space. So the 4 visible skyscrapers that go along the top row of this puzzle must be the 1, the 2, the 3 and the 4. The 1 must appear first, then the 2 afterwards, the 3 afterwards and the 4 after that. Can we ever put a 4 in a corner? No, because the corner only has 3 possible neighbours. And can we ever put the 4 here? And the answer is still no. Let's just play that out just to show it. I think it's visualisable, but I'm going to do it anyway. It means that, well, this cell can never be visited because it's a cul-de-sac. We can never get back out of it once we go into it. So all of these other 4 must be on the route. And as soon as this is on the route, then we get that corner problem. We need to come out of it, and now we've only got 2 cells left in the top row available to be skyscraper cells when we need 3 more skyscrapers. So that can't be a 4 either. So actually, whoops, we don't have a 4 there, we don't have a 4 there, so we must have the 4 there, and therefore, in order that all of the skyscrapers get seen, they must appear in that order, like that. Now, in order to satisfy the 3, in fact no, let's do the 4, because, well, the 4 just needs all of its neighbours yellow. The 3 needs all 3 of its neighbours yellow. The 2 is now satisfied, and the 1 is also now satisfied, so that will not be a road cell. Again, we might find out later that it ends up being a skyscraper cell, but I think the easiest way to solve these puzzles is to colour in grey something that you know is not going to be part of the route. That means that this has become a corner, so we can draw that in. This is this is a corner, so we can draw that in, and now that is a corner, so we can draw that in. We can't close the loop like that, so the loop does have to continue like that. Now, we can't necessarily just connect those up straight away, because the loop could go off and do, whoops, not that, something like that, and it would still be visiting all 3 of those cells, just not in a row necessarily. Okay, what's the next deduction? Let's colour that yellow. Right. So, the next deduction is to do with this 3 clue. And I'm basically just going to ask what's possible. Can we make all 3 of those skyscrapers? And the answer is no. I'm actually going to... I'm going to do the logic in the wrong order. Let's say that I've proven to you that those 3 can't be skyscrapers, and if those 3 cannot all be visible, sorry, when I'm saying skyscrapers, what I mean is visible skyscrapers, so in ascending order, basically. They can't be that. So I will come back to the proof of that because it's a little bit complicated. It's actually easier to see it once you've seen the next logical step. So I'm going to pretend that I've proven that to you, and because those three can't all be visible skyscrapers, this one must be a visible skyscraper. You'll just have to trust me. Now, let's ask, can these two be our remaining visible skyscrapers? Well, let's try it. As soon as we do that, the root gets forced down here, and then we get this T pattern. And the T pattern is very, very important for all Sudokus with this rule set, and it will come in very handy in the 9x9. What do I mean by this? Well, can we ever have 3 road cells here, a skyscraper here, and a taller skyscraper here? And the answer is no, because if you think about the neighbourhood of this skyscraper, it's this neighbourhood, right? So they are the cells that this skyscraper sees. This skyscraper's neighbourhood are these cells. Getting my plurals and my singulars mixed up. The only difference between those two neighbourhoods is that this skyscraper sees these 3 cells and this skyscraper sees these 3 cells. So, in order to account for the difference, for the fact that this is a taller skyscraper than that, we must have more road cells, more root cells in this triomino than in this triomino. Well, if we've already got 3 root cells in this triomino, then how can we get 4 root cells into 3 cells? It just doesn't make sense. So this T formation is never allowed. Okay, so let's actually go back to proving that this can't be the case, because it's a little bit more complicated, but it relies on the same logic. Basically, we're comparing the neighbourhood of this skyscraper to this skyscraper, and again, in order for both of them to be visible, i.e. in order for that to be taller than that, we need to have more root cells in this triomino than in this triomino. Well, we've already got 2 in this triomino, so we need to have more than 2 road cells. In this triomino, it simply won't work. And yeah, that's just a kind of general rule. I think it is actually possible, maybe. No, I think if you just try putting the numbers in, if you observe that if this were to be the case, this would already be at least a 4. So 4, 5, 6 would already be forced, and then the 4 is already satisfied, so none of those get to be root cells, and then the 5 can never be satisfied. It's basically saying exactly the same thing, just kind of by playing it out rather than by kind of doing a general rule about skyscraper neighbourhoods, as I was just explaining. Anyway, so hopefully that's a satisfactory explanation that this particular thing does not work, so therefore that must be a skyscraper, and as soon as we've proven that must be a skyscraper, we get as we had earlier, and then this can't be the formation either, because the T formation never works. So if those can't both be visible skyscrapers, then only one of them can be, so we've got a maximum of 1 in there, and therefore we need a skyscraper there. That pushes this root down a little bit into here, and now we can have a look at this 2 clue. Well, we've only got 2 positions left in the column to be skyscrapers, so they must both be skyscrapers. That pushes the root this way, and therefore that turns yellow. And now, this cell, well, it's got 1, 2, 3, 4, 5, 6. Whoops! 1, 2, 3, 4, 5, 6 root cells surrounding it. So, well, we don't have any digits in this 6x6 Sudoku higher than 6. I have recently released another Sudoku where you get 7s in 6x6 grids, so go and have a look at that if you like. But yeah, we don't have that here, so that is maxed out at 6 now. So now neither of those can be skyscrapers, and the root is pushed down like that. Now, if this is a root cell, then this is going to be a 4 and this is going to be a 2, and if it's not a root cell, this is going to be a 3 and this is going to be a 1. Right, let's do, you won't believe this, but let's do some normal Sudoku. Those 2 cells are 5 and 6, and this one can't be a 6, so that's a 5, that's going to be a 6, that puts a 6 down there, but also in this box, a 5 can only go there as well, so that becomes a 5-6 pair. Now let's ask, can that be a skyscraper? Well, it already has 4 neighbouring cells on the root, so it needs to be at least a 4, but it can't be a 4 or more by Sudoku, so that is not going to be a skyscraper. So the third skyscraper that must exist in this row goes here. We can do a little bit more connecting up. This now does have to go straight across. And now let's have a look at this 2 clue. So we need to have a skyscraper that is taller than this 4 in order to peer over the 4 and be seen from this direction. So that must be the 5 or the 6. Can it be this one? Well, if it is this one, that would have to be the 5, right? Because it only has 5 possible neighbours that could be root cells. Except, well, if we did that, then how are we ever going to access this cell? We can never go in there and escape again. It's a cul-de-sac. It's not allowed. So therefore this must be a skyscraper, and that does wonders for the root. It pushes it all the way through here. But it doesn't actually tell us whether that skyscraper is going to be a 5 or a 6, because it could come up here, or it could not. And it could still be 5 or 6. Eloquently explained there. Right, actually, let's have a look at this skyscraper, because it already has 5 neighbouring cells on the root, and it can't be more than 5, otherwise it would be 6. So that must be a 5, and that means that can no longer be on the root. This already has 3 neighbouring cells on the root. It could be potentially 4, so that is a 3 or a 4. There's a 5 here by normal Sudoku. Whoops, there's a 5 here by normal Sudoku. This is a 4 now because it's got 4 neighbouring cells on the root, and this is a 2. That puts a 1 and a 3 in here, 1 and a 3 in here. What am I missing? That's a 4, that's a 2, that's a 1 or a 3. This is 1, 2 and 3. I think that's all we can do at the moment. Right, good. I'm going to indulge myself in a little bit of a tangent at this point. Now, an earlier draft of this puzzle didn't have this 2 clue in, and it turns out that with all of the other clues, there are actually 3 possible solutions. There are 2 possible routes for the loop, and one of those routes ends up with a deadly pattern of 1s and 3s, so we didn't want that one. So I have put this 2 clue in just to put us on the right path, literally, so that we don't end up with any deadly patterns. But actually, once you've got that 2 clue in, you don't actually need this 2 or this 1 for any reason other than something that I'll explain at the end. So yes, those are kind of red herrings in a way. But yes, let's have a look at this 2 clue. We need to have a skyscraper cell in here, because however tall that is, it's going to obscure that 4 skyscraper, so we must have a visible skyscraper in here and one there as well. If we put it here, what could it be? Well, it would need to be less than that, and it's already at least 3, because it's already got at least 3 neighbours. So it needs to be a 3, 4 or 5 basically, but it's not a 3, 4 or 5. So that cannot be a skyscraper. Can this be a skyscraper? If it is a skyscraper, it pushes the root all the way around through the corner like that, and then it becomes a 6, because 1, 2, 3, 4, 5, 6. And of course that is going to obscure that skyscraper. So that's not allowed either, therefore this one must be a skyscraper. That means that this can no longer be part of the route because it's a cul-de-sac, so the route does continue down like that. That's going to be yellow now. Therefore that becomes a 3 because it sees exactly 3 root cells. This is going to be a 2 or a 3 depending on whether this one is in or not, but obviously it can't be a 3, so it is a 2, which means the root is pushed that way and into that corner, and that completes the root. Those 2 are not going to be root cells. And at this point it just becomes normal Sudoku. That cell sees everything except for a 6. That 3 does some damage in here. That becomes a 3. That's a 1. That's a 2. That's a 1. That's a 3. This is a 6 now because it sees exactly 6 neighbouring cells on the root. what am I missing? This is a 4, 5 pair. How does that get resolved? Oh, because that's a 5 to complete the column, so that becomes a 4, that becomes a 5. We get a 4, 6 pair here. That's a 4, which resolves the 4, 6 pair. 6 goes into there. This is 1, 3, and 5. The 5 goes there. 3, 1, 3, 1, 1, and 2. A first-class solution. That is it. So, although we've finished the Sudoku, there are 2 ambiguous cells in terms of their shading, and that is now the only reason for this 2 clue and this 1 clue. So this is the only cell within this row that has the ability to be a skyscraper. That would be bust because it sees 3 neighbours, and that wouldn't be nearly enough because, well, the 3 neighbours that this one sees aren't enough. So this one does have exactly 3 neighbours on the line, so we promote it to, green, and this one, well, that has exactly 3 neighbours on the line. What's going on here? Yes, okay, and so we can promote that one to green. So that's just resolving some ambiguity about how to shade the remaining cells. It doesn't actually help with the Sudoku at all. So those 2 clues are red herrings if you're trying to use them for the Sudoku. Right, that's enough practice. Let's get on with the main event, the 9x9 Postman Problem. Which does have 2 extra paragraphs of rules. One just says the inequality sign points at the lower of the digits in the 2 cells. That's just saying that this digit is going to end up being bigger than this one. And the last paragraph, you can't afford to waste any time stuck behind any pesky pedaling pianists on their 2 crocky wheels. So make sure that adjacent digits on your route are never consecutive or in a 1-to-2 ratio. I have no idea why anyone would ever have any problem with the way I word rules. Okay, maybe I was going a little bit flowery in that particular paragraph. But yeah, it's hopefully a fairly non-controversial rule set. That's basically just saying that if we discovered that that was part of our route and that we discovered that this digit was a 4, we can't have a 3 or a 5 here because then they would be consecutive, which is what a white crocky dot usually indicates, and it's effectively just a negative constraint against the white crocky dots. And also it couldn't be a 2 or an 8 because that would require a black crocky dot because those digits would be in a 1-to-2 ratio. And again, it's a kind of negative constraint against that. Anyway, hopefully that's fairly clear and uncontroversial. So let's get on with the solution. And the first place to look is, of course, this 7 clue. This 7 clue is telling us that there are 7 visible skyscrapers in this column from the direction of the clue. That means there must be at least 7 skyscrapers in the column. But we can also ask, how many root cells are we expecting to see in this column? Well, we need to get to this area of the grid because we know there are going to be 2 skyscrapers somewhere down this column, and we also know that there are going to be, well, skyscrapers down here and here, so we're going to have to enter this area of the grid somehow as well. We're going to have to enter both west and east of this column, and because we know that the route is a loop, it must go both sides. So as soon as we go into the east area of the grid, at some other point we must come back and re-enter the west area of the grid. So there will be at least 2 root cells in this column, possibly more if we kind of dilly-dally and go on a kind of zigzag route along there. So there are at least 7 skyscraper cells and at least 2 root cells in this column. Well, that's 9, so it needs to be that. It can't be any more than that. It must be exactly that. So we must have all of the skyscrapers must be visible. They must be in ascending order, starting from here and going downwards. And yeah, we must have exactly 2 root cells in here. And because we can't now dilly-dally, we can't mess around with any kind of zigzagging through this column, because that would mean we don't have enough space for all of the skyscrapers. We know that where we do pass through this column, it will be a kind of straight triomino like that. It will be a straight route straight through like that. Okay, so let's ask the question, can that be a skyscraper? Well, if it is a skyscraper, it needs to be visible over 6 other skyscrapers before it in the column, and therefore it needs to be at least 7, but it only has 5 neighbouring cells, so it was a maximum of 5 if it's a skyscraper. So yeah, that does not make sense. It must not be a skyscraper, so it must be one of the two places where our route passes through the column. And now let's ask, where is the other passing place? Can the route pass at the top? And the answer is no, because if the route passes through the top, then we will have a T formation. If you watched the solution guide for the 6x6, you'll know what I mean by that, but I'll just go through it again. This skyscraper's neighbourhood is these 8 cells really, because the skyscraper itself will never be a root cell. So that's the that's the neighbourhood of that particular skyscraper, and this skyscraper's neighbourhood is these 9 cells. These 6 cells are in common, so the only difference between those two neighbourhoods is that this skyscraper sees these 3 cells and this skyscraper sees these 3 cells. So in order for this skyscraper to be visible, i.e. taller than this one, visible from the perspective of this 7 clue, we need to have more root cells in this triomino than in this triomino. Well, if we already have 3 root cells in that triomino, how are we ever going to get 4 root cells in that triomino? It just doesn't make sense. You can't fit 4 into 3, not in this context anyway. So that T formation is never going to work. So the root can't pass through there and create a T formation there. It can't pass through there because that would create a T formation. And this is because we know that all of the 7 skyscrapers in this column must all be visible. It can't be there, it can't be there, can't be there. So it is going to be either here or here where the root passes through. So all of these 6 cells must be skyscrapers, and they must effectively form a kind of thermometer where we have a 1 or a 2 here, 2 or a 3 here, so on, up to a 7 or an 8 in the tallest skyscraper. Why can't the tallest skyscraper be a 9? Well, that is because if we made a skyscraper with a 9 in it, well, it only has 8 neighbouring cells. As I've said before, the root cannot pass through the skyscrapers themselves, so yeah, every skyscraper is a maximum of 8. So yeah, we don't know where the final skyscraper goes, but it's going to be one of those two. Right, let's look at this skyscraper. This is a 4 or a 5. In other words, it's at least 4. It can get 3 of its neighbouring root cells from the east side of this kind of high street, if you like, but it must have at least 1 from this side as well. But this area of the grid is like a kind of chimney where, you know, we can go into it, but once we're into it, we have to we can't kind of zigzag at all, because then we get stuck. Once we're into it, in order to maintain the loop of the route, it must kind of do a U-turn straight away and come straight back down again. So what did we say? We said we needed to reach at least this cell in order to satisfy that if it's a 4, and that must be achieved by coming straight up there. Like I said, we can't kind of zigzag at all, and then when we're coming back on the way down, the route must go straight through here. In fact, it must go there because we can't just close the loop there. So those are all definitely going to be root cells. Okay, how many skyscrapers can we have in this area of the grid? And the answer is 1, because, like I said, somewhere along this kind of pair of columns we're going to have a U-turn, and that's going to be it for the route along this area of the grid. It might go a little bit higher and then it will just do a U-turn, but wherever it goes we can have a skyscraper kind of sitting just on top of the route, which will be a 2 because it sees 2 neighbouring root cells. But then any skyscrapers up here would be of height 0 because the route can never reach there without getting stuck. So we can only ever have 1 skyscraper, just kind of, which will be a 2, just sitting on top of the route at this point. So I'm going to do that. That's not particularly accurate notation, but yeah, we know that one of those 4 cells will be a 2, which will be a skyscraper. So where does the second skyscraper come from in this column? Well, it has to go here. That's a skyscraper. That forces the route to go like that and like that. That becomes a root cell. It also forces the root to go like that, and we know that it goes straight through this column now. So those both become yellow, and now the final skyscraper. Sorry, I thought I heard a cat. Maybe I didn't. The final skyscraper in this column must be here, which is a 7 or an 8. And we can fill in this digit, because it's a skyscraper with exactly 3 neighbouring cells on the root. So the first digit of the puzzle is a 3 in the corner. That goes out to all of you Cracking the Cryptic fans. If you don't understand why confetti just came out, it's a long story. Okay, right. The next logical step is probably the hardest of the entire puzzle. So if there are any keen solvers out there, expert solvers out there, who can spot an easy thing to do next, please let me know. Well, actually, there are easy-ish things you can do with this 3 clue, and we will come back to that. But I don't think you can then continue to proceed with the puzzle without doing the difficult logical step that I'm referring to. So I'll explain it the way I know it, but please let me know if you think of anything more concise or more clear. The question, I think, is fairly obvious. Can any of those be 2s? We know that one of those 4 will be a skyscraper of height 2, and it would be really powerful if we could rule that out from being rule all of those 3 out from being 2, because then, yeah, we'd be away. We'd have a skyscraper there, and that would give us all sorts of information. So, if any of those were a 2, it would automatically knock 2 out of here. So we would get 1, 3, 4, and then the thermo would have this domino effect going down this entire column. Okay, is that possible? And the way that I'm going to prove it's not is by looking at the kind of T formation type stuff again. So, the difference between the height of these 2 skyscrapers is 1. And the difference between the 2 neighbourhoods of these 2 skyscrapers is that the 6 sees these 3 and the 7 sees these 3. Therefore, in order to account for that difference, we must have exactly 1 fewer root cell in this triomino than in this triomino. In fact, in this particular example, it's very clear to see that the 6 would need all of those to go in. But yeah, the most important bit is that we would need 3 there and 2 there to account for the difference between those. So once we've got 2 there, well, the difference between these 2 is also 1. So once we've got 2 there, we must have 1 in there. Don't know which side yet. Let's put it that side. And that is a problem. And that leads to another kind of general case theory about this rule set, which is whenever you have a skyscraper of height 1, we can never enter any orthogonal neighbours of that 1 with the root, because we can come into an orthogonal neighbour, but then how are you going to get out? You have to go either there, in which case now the skyscraper has 2 neighbouring cells on the root, and the 1 is incorrect, or that way, where again we have 2 root cells in the neighbouring cells of that skyscraper, so we can never have any orthogonal neighbours on the root. Instead, it's going to have to be something like this, where it kind of dips into a corner, into a diagonal neighbour of the 1, and then straight back out again, like that. So, that's all quite a long-winded way of saying that this is not going to be allowed, because in order to make that part of the root, we're going to have to do something like that, and then that 1 would have to upgrade to 2. So that does not work. That seems quite bifurcatory. I feel like it's a lot more visualisable than I've kind of implied by writing it all out. I feel like you can maybe visualise it all without typing it all in. But yes, it's quite a difficult point to see. But I think it's okay, because the question that leads you to that answer is an obvious question to ask, hopefully. Anyway, let's move on. We have proven that those cannot be 2s, because that would lead to that eventuality where we get a 1 with an orthogonal neighbour on the root. That's going to give us loads of progress, because now this is a 2 and it is a skyscraper, so the root does do its U-turn just here. And now, well, if we look at this skyscraper, for example, well, given the fact that none of these can be on the root, this is now a maximum of 5. but we also know it's a minimum of 5 based on the digits that we've entered as possibilities, so it must be a 5. That's going to have a domino effect going up the column. In order to satisfy the 4, that needs to be in order to satisfy the 3, that needs to be in, and now the 1 is also satisfied, so that is not in, so we do get that corner as part of our root. That becomes yellow. Now this is just a 7 because we can count 1, 2, 3, 4, 5, 6, 7 neighbours, and that means that has to be an 8, which means this goes into the root. Alright, nice progress. Okay, now let's have a look at this bottom row, and this is the bit of logic that I mentioned that isn't actually affected by what we've just done, so you can do this bit first. I just don't think you get any more progress beyond that, unless you do the step we just did. And it actually relies on this inequality sign, which is much more than just a little disambiguator at the end of the puzzle, which I quite like. A lot of inequality signs just get used to resolve some kind of deadly pattern or something at the end of a puzzle, but this is much more than that. We get a 1 or a 2 here. Now, the 3 visible skyscrapers going in that direction, can the 3 be one of those visible skyscrapers? Well, if it is, we need to have 2 shorter skyscrapers in front of it, i.e. a 1 somewhere over here and a 2 somewhere over there. And that is the reason for the inequality sign. We can't have that, we can't let that happen, because then we'd get a 1, 2 triple, effectively, in this row. That cell would be broken if we had a 1 skyscraper over here and a 2 over there. I'm getting into repeating myself mode. I do apologise. I've been recording this video for way too long, but I did warn you, and hopefully you've put me on 2 times speed, 2 times playback speed to get through all of this a bit quicker. Anyway, the conclusion of that is that this 3 cannot be a visible skyscraper. So the 3 visible skyscrapers that we must have must be only one of 1 and 2. Can't have both of them, otherwise we'll break that cell. And then a 4 and a 5. We can never have any more than a skyscraper any taller than 5 along an edge, because the skyscraper only has 5 neighbours. Now, I'm going to type in what the answer is, how to distribute the skyscrapers, and then kind of prove it retrospectively. That has to be the 5. The 5 obviously is the furthest away from the 3 because it's going to tower over the other 2. The 4 and the whichever of 1 and 2 we get. Now that the 5 is in, all of those go in. Now that that's a corner, we need to draw that, so that becomes a root cell as well. And now we've only got 2 spaces left for the other 2 skyscrapers. So you can see that if I had put the 5 any further to the right, then we would be pushing these skyscrapers off the edge of the grid. We don't have enough space if we put the 5 any further right, and it can't go any further left because we know that's a root cell. So that all gets forced. That has to go up like that. It can't close off the loop like that just yet, so that goes along like that. This is a corner, so that comes up. And we said that this had to be a 4 and this had to be the other of 1 and 2, that this isn't. Well, if that's a 4, all of those become root cells. That becomes a 2 because it sees 2 root cells. That's a corner now, so those both go in, and we can fill that in like that. Right, the next clue to look at is this 4 along this row. Let's ask a few different questions. Firstly, can this ever be a visible skyscraper? If it's going to be a visible skyscraper, it needs to be seen over the top of a skyscraper that can be seen over the top of a skyscraper that can be seen over the top of a 3, i.e. it needs to be at least 6, but given that it only has 5 neighbours, it can't be at least 6. So the 3 remaining visible skyscrapers in this row must exist in these 4 cells. Now, can these 2 cells both be skyscrapers? Or rather both visible skyscrapers? And the answer is no, because that gives us our T formation, where we would end up needing to have 4 root cells in those 3 cells. So if those are not both visible skyscrapers, then these must be both visible skyscrapers. So, and that's now a maximum of 7, because that's not a root cell anymore. That's a maximum of 7. It's also a minimum of 6, because it needs to be seen over the top of something that needs to be seen over the top of. Yeah, you get the idea. It's a kind of thermo effect again. So one of these 2 cells must be a skyscraper of height 4 or 5. Can it be this one? Well, if it is that one, then, well, it can't be a 5, so it must be a 4, and it's already satisfied. So none of these would be in, and now we have a problem satisfying this one. If we maximise the number of neighbouring cells that are on the root, it only ever gets up to 4, so that's not going to work. So this cannot be the skyscraper that exists in this domino. It can't be a 5 or a 4, so therefore this must be a skyscraper, and that's our 4 or 5. Now, we must make sure that this skyscraper is taller than this skyscraper, and in order to do that, if you think about the neighbourhoods again, we must have more skyscraper cells in this triomino than in this triomino. Well, we've already got 1 in this triomino, and we've got a maximum of 2 here, so that's exactly what it must be. Those both go in. Now we cannot have any more here in this triomino, and then I've forgotten the next step. So yeah, this is all true. We can draw. Yeah, we can draw in this because we entered this area of the grid, and then we must escape that area of the grid by coming down there. And yes, we can ask, can that be a not root cell? Can that not be a root cell? Well, let's pretend it isn't. Now this becomes a maximum of 5 if we put all of these in as root cells, but how is that root cell ever going to be reached? We can't get there and back out again. It's a cul-de-sac. Not allowed, so that must be a root cell. Okay, now we can actually look at this 2 clue. And let's ask, can the 2 skyscrapers that it sees exist in this domino? Can they both be in this domino? Or are we going to have a short skyscraper here and then the 4 towering over it? Obviously, we're never going to be able to see the 2 because the 4 will definitely block the view to the 2 skyscraper. So can these both be skyscrapers? Let's ask that. And the answer is, well, this skyscraper is a maximum of 5 if all of those are skyscrapers. All of those are root cells, but it can't be 5 and it also can't be 4. So actually, that's just not going to work. So even if this was a skyscraper, it's going to be less than the 4. So the 4 will still be visible over it. I feel like that's quite a clumsy way of explaining what was going on there, but yeah, the conclusion that we reach is that these cannot both be visible skyscrapers. So we must have 1 visible skyscraper in this domino, and then the other visible skyscraper in this row is this 4. Can that visible skyscraper be a 1? Well, hopefully, clearly not, because this 1 would have an orthogonal neighbour, and we can never have a 1 skyscraper with an orthogonal neighbour on the root, and then same here. So we're going to have a 3 here or here, because it can't be a 2 either, and that skyscraper will hide underneath this 4, or will be seen underneath. You get what I'm trying to say. Right, if this is a 3, if this is a skyscraper, then it's not a root cell. I think we can all agree on that. If this is the skyscraper, then this is still not a root cell, because the 3 is now fully satisfied. It's got all of its root cells. Either way, this is never going to be a root cell. So let's actually make it grey. We may upgrade it to green if we find out that this is the 3 skyscraper, but let's make it grey for now. That means that this has become a corner, so we can draw that in, make that a root cell. And this is now a maximum of 5, because that's no longer a root cell. That has to be what we make that. We can't make it any lower than 5. That means that has to be a 4, which means that can't be part of the root, because the 4 is now fully satisfied, and that, just by counting, is now a 7. Okay, let's look at this column. Can this be a visible skyscraper? Well, because it's on an edge, it's a maximum of 5, and so it can't be 5, so it has to be less than 5, so it's not going to be visible. Can these both be visible skyscrapers? Can this 5 not be part of the count of 2 visible skyscrapers in this column? If these were both visible skyscrapers, well, that gives us a problem with this row, because of this one clue. If this was a skyscraper lower than 7, then both of these would be visible. In fact, the only way to have a skyscraper in this row as well as this 7 is if the skyscraper is an 8 that blocks the view of the 7. And that's not going to work in this instance because that can't be a root cell, so we can't surround the 8 skyscraper with 8 root cells. We can't have the 8 there. We could also theoretically have the 8 before this skyscraper, kind of blocking both of them, either there or there, but either way it's just not going to work. That only has 5 neighbours, and that, once you've made both of these into skyscrapers, only has 6 neighbours. So yeah, that's not going to work to have both of those as visible neighbours. So we must have one visible neighbour in, one visible skyscraper in this domino, and then the other visible skyscraper must be the 5. Again, yeah, for basically the same reasons, this can't be where the visible skyscraper exists, because it's either less than 7, in which case this clue should read 2, or it's 8, in which case, what's wrong with 8? In which case it blocks this 5. We've already proven that it can't be an 8. So it needs to be less than 5 in order for the 5 to be visible, but in being less than 5 it's also less than 7. And yeah, there's no way to make this one clue work by putting, if we put a skyscraper there. So that ends up being the skyscraper, which is at least 3 because it already sees 3 root cells, and it needs to be less than 5 so that the 5 remains visible. So it's 3 or 4, and it's not 4, so it is 3. And because it already sees all 3 of its root cells, all of those become greyed out, and that's going to give us loads of progress with the root. We can push the root up through there, and now in this area of the grid, this kind of 2x3 area, how many loop ends are we expecting to enter this area of the grid? So basically what I'm asking is, can we do that? Well, if we did that, then we could connect up the loop here, but then that would be a loose end. We could connect up the loop here, but that would be a loose end. You get the point. We need to have an even number of loop ends entering this area of the grid, so that bit of the route must turn that way. And because we can't do any diagonal crossing or anything like that, we can just finish off the loop like that. We can also join those up. We can join those up because it can't go straight up anymore. Now, let's look at this 2 clue. We've got a 3 here. Can this be a skyscraper? Well, yes, it can be a skyscraper, but if it is a skyscraper, it's of height 5 because it has 5 neighbours on the route. And so that would block the view to this 3, and so we would still need, whether this is a skyscraper or not, we still need another taller skyscraper over here to satisfy this 2 clue. Is that skyscraper going to be here? Well, if it is, it's a maximum of 5 if all of those are root cells, but it needs to be a minimum of 4 to be seen over the 3. It's a minimum of 3 anyway because it already sees 3, so it's a 3, 4 or 5, but it's not 3, 4 or 5, so that cannot be a skyscraper. So we must have a skyscraper here. At the moment it's a 5, but it could go up to being a 6 if that ends up being a root cell. Obviously it can't be a 5, so it must be a 6, and that must be a root cell. We can do a little bit more drawing at this point. This is a corner, so it goes like that. It can't turn right, otherwise it will hit a dead end, so it just goes up like that. That becomes a root cell, that becomes not a root cell, and we're almost done with the root actually. This 3 now can't go here because this has 4 neighbouring root cells, so the 3 goes here, and indeed it does have its correct count of 3 neighbouring root cells. This 2 clue, let's see what we can do with that. Well, at the moment we only see the 6. We can't see the 5 because it's hiding behind the 6, so we need to have another skyscraper lower than 6 to satisfy the clue. Can it go here? Well, if it was here, it would be exactly 4, and it's not 4. Can it go here? Well, if it went there, it would be exactly 5, and it's not 5. So it has to go here. it's either a 3, or if that's a root cell then it'll be a 4, but it can't be a 4, so it is a 3, and that therefore cannot be a root cell. So we can draw our root further along like that. And that is actually all of the kind of Postman Problem element to this Sudoku. We are basically finished with that. So now we can have a look at this bottom paragraph of the kind of negative constraint along the line. Actually, we can do some normal Sudoku first, because that's been a 1 for absolutely ages, and I apologise that I didn't fill that in sooner. Where does a 2 go in this box? It can't go there, can't go there, can't go there, and because of this kind of negative constraint, it can't go there because that would require a crocky dot between those two, so that becomes a 2. Actually, even simpler than that, where do the 6 and the 9 go in this column? Because of that 6, we have a 6 and a 9 that way round. These remaining 3 digits in the box are 4, 5 and 7, but the 4 and the 5 must be kept apart from each other because of the crocky rule, so the 7 kind of chaperones them. Okay, along the bottom row we have 7, 8 and 9, but the 8 can't go in this domino because then it would definitely be next to either a 7 or a 9 and therefore require a crocky dot, so the 8 goes there, and that becomes a 7, 9 pair. 3 in this box, we have 4 3s looking into the box, so the 3 goes there. The 2 in this box goes there, well there by normal Sudoku, but it can't go next to a 3, so that's a 2. Now the remaining digits in this box are 1, 4, 7 and 9. Those aren't 9s. That's not a 7. It's also not a 1 because it's next to a 2, and it's not a 4 because it's next to a 3. So it is a 9. That becomes a 7. That becomes a 9. This becomes a 1, 4 pair, which gets resolved by this 4 up here. The 4 in the middle box by normal Sudoku goes in this domino. The 2 in the middle box by normal Sudoku goes in this square, but it can't go in this domino, otherwise it would form a 2, 4 pair and require a black crocky dot. So the 2 goes there, but it can't go there because that's next to a 4 as well. So that becomes the 2, and that actually knocks the 4 into this position. This 4 actually has been resolving that for a while, hasn't it? These 3 digits must be a 1, 5 and 6, but again the 5 and the 6 must go apart from each other so that they do not require a crocky dot, so the 1 kind of chaperones them, and the 5 resolves that for us. This is 7 and 8, and that's just resolved by normal Sudoku. This box, I think, is the next one to look at. I'm just trying to remember the solution on the fly. So those are the 5 digits we have available. 1s can't go there, 3 can't go there. It also can't go next to a 2, and it can't go there. So yeah, that's given. 6 cannot go next to a 3 because that would require a black crocky dot, and it can't go next to a 5 because that would require a 5 crocky dot, a white crocky dot. So that is the 6, and we get a 1, 8, 9 triple, which we cannot resolve. In this box, I can't remember the quickest route, so I'm just going to do the long way round again. Let's just eliminate 1s from there, and also those 2 positions because they're next to the 2. Let's eliminate 5s from there, and also that position because it's next to the 4. We'll eliminate 6s from there, and that's it. 7s from there, 8s from those positions, and also next to the 4 because because that would require a black crocky dot. And 9s can be eliminated from those 2 positions, so that is a 7. Yes, I knew it was something to do with 7s. So 7s now come out of those positions. 7 in this row now can only go there. This is not a 1 or an 8, so not 2, 6, 4, 3 or 7, so it's only a 5 or a 9. That creates a 5, 9 pair in the row, and that becomes a 1 or 8. 2 in this box just by normal Sudoku goes here, and that leaves a 1 or 8 pair to complete the column. Now this is probably the hardest bit of normal Sudoku remaining in the puzzle. What you need to ask is, can this be a 1? If that is a 1, that puts a 1 there, and now there's nowhere to put 1 in row 3 of the puzzle. We can't put it there because of the 1 we're hypothecating just here. We can't obviously put it where there's already a different digit. We can't put it there because of the 1 in that box, and we can't put it there because the 1 in that box. So those cannot be 1s. They must instead, well, this is an 8, therefore that's a 1, therefore that is also an 8. We can't put 9 here because that would be consecutive with 8, so that's a 5. That becomes a 9. We can take 9s out of here. I thought that ended up being... Oh yes, there's a 1 there. So that's a 6, that's an 8, and that's a 5. These 3 digits are 5, 7, and 1, but this 1 isn't a 5 or a 7, so that's a 1, that's a 5, 7, but 7 can't go next to an 8, so it's resolved like that. These digits are 6 and 9, but 9 can't go next to an 8, so 6 and 9 go in like that. This is not 1, 2, 3, 4, 5, 7 or 8, and it's not 9 either because it can't be next to an 8 on the line, so it's a 6. This puts 8 and 9 over here. 8, 9 pair in the column means that we're left with 5 and 7, and that is resolved. This is 4 and 6, and that is also resolved. The remaining digits along here are 2, 4, 8. The 4 and the 8 makes that a 2, and the 8 makes that 8 and 4. The remaining digits here are 1, 3, and 9. 1, 3, and 9. 3s can't go next to 6s because of the black crocky negative constraint, so that's a 3, and the 9 will help us out with that bit. Right, sorry about that. I've just messed up the ending because I completed the puzzle and then it didn't come up with the success message that I wanted. So that's a very good reason to go and spend 5 minutes remaking the link, updating it all, and then re-recording this last bit of the video, because it's very important that you see the success message that I came up with. So 2s in this box go there by normal Stokey, that's a 3 by normal Stokey, that's a 4, that's a 6 by normal Stokey, that becomes a 9, that's a 1, we get a 9 there, 9 there, 8 there, 8 there, and that's a 1, and you are a postgraduate! Yeah, that was worth re-recording. I hope you enjoyed that pun. Right, but you may be wondering what's going on over here. Well, we can actually resolve where the route goes, because we can never pass through there because that would be that would require a white crocky dot. We could never pass through there because that would require a black crocky dot. In fact, we don't even need to know that, because as soon as you know that, the route can never do something like that, because then you would never see this route. We know the 3 needs to be part of the route. We can never do like that. We can never do something something competent, something like that. Yeah, it's just not going to work. So yeah, you do actually find eventually that it goes straight across like that, and those become grey. I'm going to get rid of that cross because it's annoying me. And another little bonus feature you may have noticed is that I believe the only cell in the grid that is not currently a skyscraper but has the ability to be is this 2, in the sense that it sees 2 neighbouring cells that are on the route. But obviously we can deduce that it must not be a skyscraper cell because of the 1 clue there, because if it was a skyscraper we would be able to see 2 skyscrapers from that direction. And yeah, so whereas with the 6x6 puzzle I've put some clues in at the end just basically to disambiguate between grey and green and say, yep, these can be skyscrapers because why not? In this case, we actually needed that to be a 1 for some of the logic that we were doing around this column. And yeah, we get that as a grey 2, not a green 2. Now, I am just going to finish off by being a little bit self-indulgent and just kind of talking about the construction process and about the puzzle and how happy I am about the puzzle, which is honestly very happy. I think this is a really cool puzzle idea, and I feel like I executed it pretty well. I think the break-in with this 7 column is pretty good. It's quite hard to understand exactly how the numbers get distributed, and it does require a little bit of visualization and arguably maybe some bifurcation, but I think that's about as hard as it gets. And certainly once you understand some of the kind of general ideas about the triominoes and the T formations that I was talking about earlier, and how you can never have a road cell orthogonally adjacent to a skyscraper of height 1, those kind of general rules do help you a long way, and I think I did quite well. What I would say though is that when I made this puzzle, it was originally my idea that the line that you draw, in this case the red line, would be some kind of well-known Sudoku line type, by which I mean maybe German whispers or equal sums or something like that. And I really wanted that to be the case, and I thought it could give rise to some really cool logic if there's some kind of clever interactions between this kind of Postman rule set and whatever rule set I go with on the line. But I made a fatal error, and the fatal error is that I basically got as far as I could with the Postman rule set and put in as many clues as I could to determine as much of the grid as I could, and then I basically just analysed the options left on the line to see, does German whispers work here? And you can see, for example, here it does actually work for a bit, but then obviously there's a 5 on the line, and so German whispers would break at that point. And equal sums just isn't, well, it's not going to work when one of the line segments is just a single cell like that. So yeah, those all ended up breaking, and that's because I had designed far too much of the puzzle by that point, and it was all way too restricted. And yeah, those line types would never have worked. And so what ended up happening is I went for a much kind of less restrictive rule set, just this kind of negative constraint on Crocky dots, and yeah, it's much looser, and you don't really get much interaction between the Postman rule set and the line rule set now, as you might have done. You don't get as much as you would have done if if it was a much more restrictive rule set like German whispers or equal sums. So I think if I did this again, I think I would just commit right from the beginning. I would say this is going to be a German whispers line, and then I'd have some kind of break in like this 7 column, and then straight away I would think, right, now that I know that it's a German whispers line, what are the restrictions? And in this case, well, it wouldn't work because there would be a 6 here, and so it would have to be surrounded by 1s on both sides. So yeah, that wouldn't work. But I would analyse it like that, and I would not continue to write in Postman clues, clues of the Postman rule set, until I had done everything I could with the German whispers one. So yeah, that's what I would do, and I think by doing that, it would create a puzzle where there's a lot more kind of back and forth between the two rule sets, and yeah, a lot more interaction and a lot more interest that way, because this solution path for this puzzle, it kind of is just do the Postman bit, design your route, find all the skyscrapers, do that half of the puzzle. Then the second half of the puzzle, a completely separate puzzle, effectively, is there's an anti-Crocky constraint on the line. It's like it's 2 separate puzzles, and I just wish there was a bit more kind of mishing and mashing between the two along the solution path. That's all I'd say on that. If I were to design this puzzle again. Having said that, really the main point of the puzzle is the Postman rule set. That's the most interesting and unique part of this puzzle. So I don't think it's the end of the world that is basically the main puzzle that you're doing for the first kind of 2/3 of the solution path, and then the rest of it is just basically a disambiguator at the end. I don't know. I'd be interested to hear what your thoughts are on that, and aesthetically and in terms of the kind of logical path. Is that a mark against this Sudoku? The fact that you don't really get onto the line rule until much later, and of course, if any constructors out there have been inspired by this rule set, please do take it on. Feel free to. My advice to you would be to commit to a different line type much earlier, either German whispers, equal sums, entropy, whatever you like. But yeah, commit to that a lot earlier, and then maybe you'll find a puzzle with more interaction between the Postman rule set and something else. I'm going round in circles at this point, because I never know how to wrap up videos, but I'm going to conclude by just saying thank you ever so much for watching this video, however much of it you have watched. and thank you for having a go at the puzzle. If you have had a go at the puzzle, I hope you found it entertaining and enjoyable. And I am sure I will see you around for another solution guide in the near future, or possibly even I may even attempt other Sudokus as a kind of solve in the style of one of the Cracking the Cryptic videos. I may attempt that. We'll see. We'll see how brave I'm feeling. Anyway, yeah, thank you very much for watching. Please do like, comment, subscribe, all the usual stuff. That really would help out. And have a lovely rest of your day.